For your starter task, you're looking to find the fraction of these circles which are red. So if you haven't already done this, pause the video now and give it a go. Okay, so first circle, we have 270 degrees. It's fairly clear to see from it that that is 3/4 of a circle, but we can actually work that out because it's 270 divided by 360. And if you put that into your calculator or simplify the fraction, you will find that that is 3/4. For the second fraction, we have 90 degrees. So again, full circle is 360 degrees. We have 90 degrees, so it's going to be 90 over 360, which simplifies to 1/4. For the third circle, we have 120 degrees, so the fraction of the circle is 120 divided by 360, which is 1/3. So here we can see we can use fractions of the circle using the angles that we're given, turn those into fractions and work out what fraction of the circle we have, just as we've done when we've learnt about pie charts in the past. So if I knew that the circumference of the first circle was 12 metres, we've already worked out that that red part is 3/4 of the circle. So can we work out what the length of the arc around the red sector is? So the length of the arc is this section round here. So part of the circumference that is red. So to do that, it's going to be 3/4 of the total circumference. We know that the circumference is 12 metres, and so it's going to be 3/4 of 12 metres, and that is going to give me 9 metres. And just to make sure, I'm just going to say, so that is going to be my arc length. So 3/4 times my 12 metres, and that gives me 9 metres. Another question, we're going to look at the second circle this time. So second circle, remember we said that that was 1/4 of the circle. And now we're being asked if I know that the area of the second circle is 20 square metres, what will be the area of the red sector? So if it's 1/4 of the circle, it's going to be 1/4 of the 20 metres. So the area of the sector is going to be 1/4 of the 20 metres squared, which is going to be 5 metres squared. For my third example, so if I knew that the circumference of the third circle was 15 centimetres and its area was 24 centimetres squared, what would be the arc length and the area of that red sector? So remember with this one, we said that that was 1/3 of the circle had been shaded red. So for the arc length, it's going to be 1/3 times the circumference, which was 15, which is going to be 5 centimetres. And the sector area, so my area is going to be 1/3 of the total area of the circle, which is 24 centimetres squared. So it's 1/3 of 24, which is 8 centimetres squared. So what we've got here is we've had 3 circles, they've all got different fractions, and so we've been able to work out the fraction of the circle that has been, in this case, shaded red, and we've then been able to apply that to either the circumference of the circle to work out the arc length, or we've been able to apply it to the area of the circle to work out the sector area. And this is the nature of the topic that we're going on to today. So what we're actually doing is we're going to be looking at how we can calculate the arc length or the sector area of a circle. And what we have just done is establish the relationship that's shown on this slide. So we have our fraction. Our fraction is our angle of the circle, or the angle of the sector rather, which is this bit here, x, divided by 360 degrees, which is the total number of degrees in a circle. That's our fraction. And what we can see is that that is the same as the arc length over the circumference of the circle. And it is also the same as the area of the sector divided by the total area. So we have a formula that we can use, which is x over 360, so the angle over 360, divided is equal to, the arc length divided by circumference, which is pi d, which is equal to the area of the sector divided by the total area, which is pi r squared. So let's see how we use this. So I have an example here. Find the length of the arc of the sector. So we have a sector that has 100 degrees, and we know that the radius is 8 centimeters. So what I'm going to do is I'm going to have a look at this and see what am I wanting to find out and what information do I know. So I've been asked to find the arc length, so I'm going to tick arc length. I know the angle is 100, so I'm going to tick the x to the angle. 360 is a number, I know that, so I'm going to give that a tick as well. And I know the radius. Now because I know the radius, if the radius is 8 centimeters, then I know that the diameter is going to be 16 centimeters, which means that I also know pi d. I'm not interested in the area of the sector, and therefore I'm not interested. I could calculate the area of the circle if I wished, but that does not factor into what I'm doing. So at the moment, I'm going to ignore that part of my formula. So I now have x over 360 equals my arc length over pi d. So now I can substitute my values into my formula. So x is 100, so I have 100 divided by 360, and that is going to be equal to my arc length, which is what I'm looking for. So I'm going to call that arc length, divided by pi times diameter, so pi times diameter, which is 16. So to find the arc length, I'm going to rearrange my equation to get arc length on its own. And so I get the arc length equals 100 divided by 360 multiplied by pi multiplied by 16. So I've just swapped the order so that my arc length is the subject to my formula, so it's the one on its own on the left. So when I put that into my calculator, I get that that is 13.96263. That's probably more than enough decimal places to put there. It doesn't tell me how many number of decimal places to round to, so I'm going to round that to 2 decimal places. So that is going to be 13.96, and the units are going to be centimeters, and that is rounded to 2 decimal places. So that is my final answer. Another example. So in fact, the very similar shape, the same shape. Okay, but this time we've been asked to find the area of the sector. So again, I can do the same thing. I'm going to look at what information I want to find, what information I have, and so what parts of the formula I want to use. So again, my radius is 8 centimeters, which means that my diameter is 16 centimeters. I'll write that down. So x is my angle. We know that that is 100 degrees, so I know x. 360 is 360, so we know that. Arc length I am not interested in. I can calculate the circumference if I wish. Okay, so I will give that a tick. I want to know the area of the sector, so I give that a tick. And I can calculate the area of the circle because I know the value of r, so I'm going to give that a tick. So what I have is x over 360 and area of sector over pi r squared are the two that I'm interested in. I am not interested in the bit in the middle. So I can rewrite this now. So I've got x over 360, and that equals area of sector divided by pi r squared. So now I can put my information in and calculate the area of the sector. So x is 100, so I have 100 divided by 360, and that is equal to the area of the sector divided by pi r squared. R is 8, so pi times 8 squared. And finally I can rearrange that so that I get area of sector on its own. So I'm going to have area of the sector. Again, I'm just swapping it so that the area of the sector is on the left. But that is going to be my 100 divided by the 360 multiplied by pi times 8 squared. That gives me 55.85. Which I'm going to round again to 2 decimal places. So I have 55.85. My units are centimetres squared, and I've rounded that to 2 decimal places. Okay, so now that I've done one example of each, it's your turn. Can you get your textbooks open, please, page 47, and start on the questions on exercise 7.1, and then move on to the questions on exercise 7.2. So exercise 7.1 is looking at arc length, exercise 7.2 is looking at sector area. Now you will notice that the book has divided these up. They have given you a slightly different formula. Okay. What we have done is we are treating this as one formula to learn that includes everything, so you then need to adapt, which means that the book is teaching it in a slightly different way. So if you need to, there should be iPads available. You can get another look at this video. Okay, and you will also have some notes, some printed examples that you can refer to as well. Good luck.